Right, these are your forensics notes for the fingerprinting unit. So what is fingerprinting? Fingerprinting is also known as dactylography or dactyloscopy. Your fingers, toes, feet, palms, and lips all have ridges on them, which are raised portions of the skin. And we call those dermal or friction ridges. Those ridges help us to grip objects. Those ridges on your fingers accumulate natural secretions like oils and dirt as we touch things. And then when those ridges press against something, they leave a mark or impression behind that we call a fingerprint. So there's two things a forensic examiner looks for on a fingerprint, and they're the presence of a core and a delta. We'll do a lot of practice with identifying cores and deltas. The core is the center of a loop or a whorl. So this happens to be a loop. The very center of it here would be what we call the core. And then there's a triangular region near a loop, which we call a delta. So this is kind of that triangular region. The center of that is the delta. By counting the number of deltas, we can determine the type of ridge pattern for a fingerprint. So again, core, center of the pattern, delta is that sort of triangular region. There's specific classes for all fingerprints based on their visual pattern. So we can always classify a fingerprint as either an arch, a loop, or a whorl. Arches have ridges that enter from one side and leave from the other side with a rise in the center. So for example, this one right here, it enters from the left side, rises in the center, and exits from, enters the left side, rises in the center, and then exits the right side, right? So enter, exit with a rise in the middle. About 5% of the population will have at least one arch pattern on their fingerprints. Loops are the most common type of fingerprint pattern. The way we identify a loop is that the ridges enter and exit from the same side. So either from the right side or the left side. So if you look at this loop here, if we follow a ridge, it enters from the right side and exits the right side, right? So if we follow those ridges, enters and exits from the same side, unlike an arch, which enters and exits from opposite sides. So this pattern is found in about 65% of the population. A whorl pattern is going to have at least one ridge that makes a complete circuit. So that makes a complete circle. Looks sort of like a bullseye, and it has two deltas. Those two deltas are really key in identifying a whorl. This is found in about 30% of the population. So if you look over here, we have one delta on the left side, this triangular area, one delta on the right side, that other triangular area. And if we follow these ridges in the core, you can see they kind of make these concentric circles. This is a whorl pattern. There are different types of arches. So a plain arch is when the ridges enter on one side and exit on the other, right? So again, enters the left, rises, exits the right side. Just a kind of a slow rise in the center. A tented arch has a sort of spike in the center. So it looks like kind of a delta almost in the center here. So it's still entering the left, exiting the right, but it has this high tented kind of arch spike pattern in the center. There are also types of loops called radial loops and ulnar loops. They're named for the bones that are in your arm. So we're always looking, when we look at the right thumb, a radial loop is going to open and exit towards the left or towards the radial bone. So your radial bone is the inner part of your wrist. So that loop is going to enter and exit towards your radius. Versus an ulnar, which is on your right thumb, is going to open towards the right and exit towards the right as well, towards the ulna, which is the outer wrist bone. So on the left hand, it would be opposite. Right, ulnars are going to enter and exit to the left and to the right for a radial loop. We're not going to distinguish between radial and ulnar loops. I just want you to be aware that they can open to either side. And if we know which hand it came from, they do have different names, but we're not going to worry about being able to identify them. All right, there are several different types of whorls. If you draw a line between the two deltas in the plane and central pocket whorls, if the curved ridges touch the line, it's a plane whorl. If none of the center core touches a line, it's a central pocket whorl. Right, so here's a plane whorl. We're going to identify the two deltas. So one delta is here, one delta is there. If we draw a line between those two, you can see that the circular pattern crosses that line. That tells us it's a plane whirl. The two deltas on this whirl, there's one here and one that's very difficult to see over here. But if we draw a line between those, that circular pattern does not cross that invisible line. So that would be a central pocket whirl, or this one calls it a central pocket loop. We're going to call it a central pocket whirl. That's usually a much tighter pattern, whereas the plane whirl is much larger. A double loop whirl is made of any two loops that are combined into one print. So if you can see there's like a loop here that enters and exits from the right, and another loop here that enters and exits from the left. Because there are two loops in the same print, we call that double loop whirl. Kind of makes that S shape. An accidental whirl doesn't really fall under any of the other categories. This is kind of the misfit. If it's not a clear arch, not a clear loop, or plain whirl, then it would be an accidental whirl. We don't have two distinguished deltas, so it's not a true whirl. The ridges don't enter and exit from the same side. They don't enter and exit from opposite sides, so it doesn't really fall into any category. That would be an accidental whirl. All right, so in addition to the main ridge pattern, we can also identify what we call minutia. While looking at the basic fingerprint patterns can quickly help to eliminate a suspect, in order to positively match a print found at a crime scene to a specific individual, we need to have more information. So for every individual, including identical twins, they have a unique fingerprint resulting from the unique ridge patterns, which are called minutia. We call it this because these are very tiny, small details in a fingerprint. Minutia are points where print ridges come together or where they end, and they're considered to be the uniqueness of the individual. The FBI has found that no two individuals have more than 8 common minutia. So like we said, even identical twins, they may have the same main pattern, but even their minutia are going to be slightly different. Many fingerprint experts are going to use the 12 match guideline. When a fingerprint expert takes the witness stand and says he's absolutely certain 2 fingerprints match, he means he's found at least 12 or more matching minutia. So like we said, the FBI says there's no way that 2 people can have more than 8 matching minutia. An expert is going to use that 12 match guideline. So if they find 12 minutia that are the same between 2 prints, we're going to say that those prints have to come from the same person. There's no way 2 people can have that many minutia in common in their fingerprints. All right, so there's a lot of different types of minutia. We're going to focus mostly on the ones that are the most common, but here are a couple of the different ones. So some that you will see more often are an ending ridge. So when we're looking at these minutia, we're looking at the dark part of the print. The dark portion is the ridge. So an ending ridge right here would be literally where a ridge stops, right? You can see how this ridge is going along and then suddenly stops. That would be a ridge ending or an ending ridge. There are also things called bifurcations. A bifurcation is like a fork. It's where one ridge splits into 2. So you can see here is a bifurcation. We have one ridge coming down and then it splits into 2 separate ridges. So we call that a bifurcation. An island ridge is just a small section. It's similar to a dot. An island ridge is usually a little bit bigger. A dot is just going to literally be a single point, but it's kind of by itself between 2 other ridges. You could have a bridge. A bridge would be when there's a small section connecting 2 different ridges. A spur or a hook, that one's pretty straightforward. An eye or an island, or an eye, which some people call an island. I tend to use the term eye. That's what we're going to be using in class. That's where it opens up like a bifurcation and then closes again. So another bifurcation right on the other side. You could have a double bifurcation. So here you can see this is a more complicated pattern. A trifurcation even, where it splits into 3. The ones we're really going to focus on are ending ridge, bifurcation, islands, and dots and eyes. Those are really the 5 that we are most interested in. All right, there's different types of fingerprints that we can have. So Patent fingerprints are also sometimes called visible prints. Those are prints that are left on a smooth surface by something like blood, ink, or paint, some other liquid that comes in contact with the suspect's hands, and then it transfers that to the surface. These are fingerprints that you can see without any additional equipment, right? Like this blood fingerprint right here, we can see that without any additional like dusting or anything like that. There are also plastic fingerprints. Plastic fingerprints are actual indentations left in some sort of soft material. It could be clay, putty, wax, mud, something like this over here. You can see there's a fingerprint left in this soft material. That is a plastic fingerprint. Then the fingerprints we're mostly going to focus on are called latent fingerprints. Latent fingerprints are caused by the transfer of oils from someone's hand. So they leave behind these invisible prints that must be visualized either using dusting or fuming, which is what they're doing right here. So latent fingerprints are not visible to the naked eye, but they can be made visible using a variety of different chemicals. We have different types of chemicals for different types of fingerprinting situations. When we dust for fingerprints, we dust it with a fine, very fine carbon powder to make that fingerprint more visible. Then we can put tape over that print in order to lift it. So we basically put the tape over the carbon powder and lift that powder to get an exact replica of what that fingerprint was. We can also use metal or magnetic powders to lift fingerprints as well. We will be doing a lab in class with this. It's very messy, but it's a really good way to visualize prints that are left behind by those oils. There are also processes called fuming. So fuming is when we use different chemicals in different situations to visualize a print. So we could have ninhydrin fuming. This is for fingerprints that are left on paper. So if we spray or dip the paper in ninhydrin, wait 24 hours, that chemical is going to react with the sweat from the person's hands, and you'll get this purple or blue print. So that's how we can visualize it specifically on paper. So here's like a check, for example, that was left with ninhydrin overnight. You can see the fingerprints become visible. We also have cyanoacrylate vapor. Cyanoacrylate is the main chemical in superglue. This type of fuming is used for fingerprints that are on items like that may be plastic, metal, glass, even skin. Cyanoacrylate works well for surfaces that are not smooth, so where it may be difficult to lift a print otherwise, cyanoacrylate can help us visualize those prints. What happens is we heat that sample in a vapor tent. We obviously don't want those vapors to get out, so we do it in some sort of enclosed area. That cyanoacrylate is going to react with the amino acids, and then you get this white print that appears. So we really just use the vapors, the fumes from this chemical, and in the presence of those fumes and a little bit of heat, we'll get these nice white prints. Could also have silver nitrate. This is for fingerprints that are left on things like wood or styrofoam. So wood doesn't have a super smooth surface, so it's difficult to lift prints with dusting. So we may use silver nitrate in that case. We're either going to dip or spray it in the silver nitrate solution, and then the chloride from the salt in your sweat combines with the silver nitrate to form silver chloride that has this black or red-brown color. So you can see this is a print left on wood with the silver nitrate turns this kind of brownish color. And then we also have iodine fuming. Iodine fuming is used for fingerprints that may be on paper, cardboard, any other unpainted surfaces. Again, using a vapor tent, we're going to heat solid iodine crystals. So they look kind of like this, right? Crystals of iodine. As we heat them up, those vapors combine with the carbohydrates in those prints, and we'll get this sort of brown print on the paper. For iodine fuming, it fades very, very quickly. So we have to make sure that we photograph it as soon as possible because it is not going to last forever. It's going to fade over time. All right, so a fingerprint is an individual characteristic. We call this individual evidence. No two people have identical ridge patterns or identical minutia. A fingerprint pattern remains unchanged during a person's lifetime. So the fingerprints you were born with are the same fingerprints you will have your entire life. Fingerprints have general ridge patterns that allow them to be systematically identified. So for example, we can categorize every print into a loop, arch, or a whorl. From there, we can then identify minutia. A print can change due to permanent scars or skin diseases. So some criminals, John Dillinger is a good example, have tried to alter their fingerprints with chemicals or surgery or some sort of like physical destruction of their fingerprints. Most of those are not successful because it actually leaves behind scars that are more unique than their actual fingerprint was. Fingerprints dissolved by acid are going to eventually grow back. Scars on fingers make those prints even more unique. So while it may work for a very short period of time, once those wounds heal, the fingerprint becomes even more recognizable than it was before they attempted to get rid of their fingerprints, right? So not a great plan if you are a criminal. All right, so this is the end of your fingerprinting notes. We will have a lot more practice with minutia and identifying ridge patterns in class, as well as practicing things like dusting and collecting fingerprints. Go back and rewatch this video as many times as you need to review the information. Make sure to submit your notes on Canvas when you are finished.